Welcome to another short subject from educatevirtually.com. We're going to take a look at the T statistic and the p-value. The T statistic is used when we perform a t-test to compare the differences between two averages. So let's take a look at the example that we have today. So we're going to fly two helicopters. Now these two helicopters, one has a longer body and the other one has a shorter body. Those are the differences between the helicopters. We want to find out if the body length makes a difference or not. So we're going to conduct a two-sample t-test or a paired t-test to determine the difference between the two averages of their flight time. Now because we have some environmental concerns associated with wind, temperature, humidity that may influence the outcome of the flight time, we're going to fly these together in pairs, and we're going to use the paired t-test to do that. That will eliminate any of those environmental concerns because both of my helicopters will be exposed to the same environmental conditions at the same time. So we'll fly the two helicopters simultaneously and we'll collect their data. We'd have to have a couple of stopwatches and obviously a few people to do this. We're trying to find out if the body length maximizes the flight time. So we've collected our data and now we can conduct our t-test. Well, the t-distribution is the distribution of the differences. And it has a distribution that looks something like this. It's very narrow and very tall. In our example, we've got 25 data points and our degrees of freedom is 23, and that gives us this distribution. There's obviously an infinite number of these based on the number of samples and degrees of freedom associated with it. So what are some of the T statistic values of note? Well, one important one is the T statistic, which can be negative or positive. The F statistic was always positive. The T statistic, its absolute value, if it is less than or equal to 1, it's of note because if we look at this distribution, we see that at a T statistic of 1, we're at a p-value of 0.3. That's a huge p-value. That means that there is no difference. If I'm at a half, my p-value jumps up to 0.68. A T statistic of 0 means there's absolutely no difference because this is the distribution of the differences. So what we would like to see is our T statistics get large, which means our p-values that give us our confidence in our decision making, we would like those to get small. So if I'm at a T statistic of 2, or minus 2, either one, depends on the ordering of the data when we subtracted the differences. But with a T statistic of 2, that gives me a p-value of 0.05. 1 minus 0.05 is our 95% confidence that there is a difference. So that's always been our line of demarcation. We would like to have p-values at 0.05 or less to be able to declare that yes, there is a difference. When I get up to a T statistic of 2.8, my p-value is now down to 0.01, or a 99% confidence that there is a difference between the flight times of our two helicopters. And that's what we wanted to find out. So as our T statistic gets larger, the p-values get smaller and smaller, and our confidence grows in our ability to make a decision that says that yes, beyond a shadow of a doubt, there is a difference between the two average values that we tested. Well, that is the T statistic and the p-value, a little bit about a paired t-test, and it's all brought to you by educatevirtually.com.